is the structure that we'll be learning about today. Okay, today's class or today's session rather will be restricted to this particular diagram. Let me show a part of it. So everything that you see in this, everything that you see in this hexagon is the CI pipeline. Everything that you see in this, in this shape, it's going to be your CD pipeline, and this parallelogram is going to be the CT and CM that we've seen in the previous slides. Okay, this is your CI part, this is your CD part, and this is your continuous training and monitoring. Okay, we'll be completely showing the CI pipeline, and we'll show the model deployment part in the continuous deployment pipeline. Okay, let's go deep into it. Okay, what is the first thing that you will do? Fine, I have come up with a problem statement. Okay, the problem statement is that I am a company that works with, let's say, a manufacturing company for automobiles. Okay, I'm an open source automobile manufacturing company. I have tie-ups with all the leading companies, like it could be a Mercedes, it could be Audi, it could be Bavarian Motor Works, it could be like the different companies that I'm tied up with. I want to build a model which will give me a prediction of the amount of material needed for the silencer or for the exhaust pipes, all the exhaust, the gaseous exhaust that comes out of all the vehicles. I need a rough estimate of what quantity of material I'll be needing to manufacture those pipes. Okay, now I do the manufacturing of these pipes. Okay, this is what my work is. I am tied up with all these leading companies. Okay, it's hypothetical, guys, so please don't think, because all these companies, they mostly have their own, manufacturing setup. But let's just enjoy this example because it's just randomly come up. So I'm sure there's going to be some fun intuitions based on this. Okay. Now they hire a team of data scientists, a team of personnels who are going to help them make this prediction. So they basically give them a certain amount of data. Okay, based on different features. There are going to be certain features of previous years that based on these features, like when a car which has this much cc engine, like this is the capacity, this is the horsepower, this is the various features are provided, and the amount of material that we needed to make the pipe or the exhaust pipe for this particular automobile was so and so units. Let's call it units. Okay, that is my regression problem. Of course, it's a regression problem, right? Now, as a data scientist, I'll obviously do some experimentation on my Jupyter notebook. I'll do some analysis. I'll do this and that. I'll just do some exploratory data analysis. I'll do feature selection and everything. Once that is done, I'll see that there are 6 to 7 features which are sort of showing the target variable, showing path to the target variable as to how it should behave. Once that is done, I push a set of files to my GitHub repository or directly to my Azure repository. There are different ways of doing it. Okay. Once that is done, I have to link it with my platform, the platform on which I wish to implement this CI/CD automation pipeline. Now, because we are showing that on Azure tonight, I will be referring to the term Azure a lot, but you can do it on Google Cloud Platform. You can do it on AWS as well. But today we will be doing it on Azure because it is one of the finest that we have. Okay. So CI/CD pipeline on Azure, this is what I have to, this is what is expected of me. So what I'll do is, I'll do the code, I'll write the code, all the experimentation will be done, I'll frame the entire model, everything will be done. Okay. Then I just link my code with my GitHub repository or my Azure repository, and I link it with my Azure account. Okay, my Azure portal basically. I'm starting a new project. I'll be showing that how that's done. Okay. The moment I do that, the next thing that comes up is the data. Okay. Now, data management is very, very important, guys. It could be like, I'll give you a very raw example for those who are absolute beginners in data science. There is a CSV file. The CSV file is there on my system. It's there on my local directory. I can directly push the CSV file. It could be a part of this repository itself. And this CSV file will be pushed into my the blob storage that I'm going to be showing you, the blob storage of Azure. Sorry, yeah. So the blob storage is there, and there I can push my data. It could be a CSV file. I could fetch it from using MySQL. There are so many different ways. But as of now, let's keep it simple. We are pushing it on Azure's blob storage, wherein all the data and all the artifacts can be stored. Okay, that's there, fine. Now, this data will change with time. I've just discussed that. I've spent like 10 minutes in discussing how data can change rapidly, okay? Or maybe slowly, doesn't matter. It will change for sure. When that is happening, I need to have the newly formed data as well, right? So the newly formed data that I have will be version 2 of the data. Again, the data changes after some time. There's going to be version 3. So you can either have different versions of the data, or you could feed in real-time data continuously, and then the real-time data is going to, your model will be trained on that real-time data, and then the outputs will be shown on the metrics, as we are going to see later. Okay, so this is going to be the data management part. The next part is model building. Now you've already written some script over here, but you need to build the model. You need to train your data set. There has to be training done. The training has to be, now when the training is done, there are some scores which are generated. The testing will be done after train test split. These test scores that I get, the test scores that I get, they need to be provided, right? I need to see like what is the performance of my model. Okay, I'm using I could use an SVM, I could use a linear regression. There were so many different algorithms that I have. Which one is performing best for this particular task? So the different metrics, the different performance metrics of these models are compared. Everything is there for you to see, and that is done during this model building process, wherein you're training your model precisely. Okay. Once that is done, you come up to the model management part. What is the model management part? You could say that model management and model profiling are closely related. Okay. Now think of it like a business, like this. Like there's a business which needs one or two models only. Like it is not. It is precisely a business which needs just one or two machine learning projects or one or two machine learning concepts to run or concepts to be implemented for its growth. So for that, what do? We basically have one or two models which do not need that much of discrepancy or that much of distinction, not discrepancy, that much of distinction. They're running independently, and you just need to monitor their performance and manage their behavior. That's it. That's all you need to do. What if you have a lot of models, you have different algorithms? What if you want to change something? What if there are different requirements for different models? So what do you do for that? For that, you use the concept of model profiling, wherein you can register the model. The requirements are there. There are different memory requirements. There are, the profiling of the entire model is done. Okay. So when I am a machine learning engineer working for this XYZ company, and they've asked me to determine that how much material will I require to manufacture any exhaust pipe or any pipe which releases the gases which is generated as a result of the combustion process that takes place. Okay, well, how do I basically predict that? When I do that, I use a number of models. I use different hyperparameters for them. All the profiling, that which one performed best, all that profiling, the registry. Okay, it's like a document which has details about these models. They are going to be registered, and everything is going to be stored in a very decent way. Okay, in under a particular segment, I'm going to be showing that we have a different workspace for this, and that's how it's going to be generated. All the details are going to be mentioned there, so I'm going to be showing that as well. This entire chain, right? You start with the management of the code, you build the repository, and when I actually show the CI pipeline implementation, I'll walk you through this. Okay, so please remember these steps. We have code management, data, the model building. Model management and model profiling happen hand in hand. Okay. Once this is done, my CI pipeline is established. That's kind of interesting. Now I come to the CD pipeline. Okay. What is the CD pipeline? I have a model which is working really well, and I'm kind of satisfied. It's given me a 98% accuracy. That's fantastic. This model will have its own pros and cons other than the accuracy. Okay, depending on the size of the data, depending on company policies, there could be so many things, right? So I will have a managing team. I will have a technical head who needs to approve my proposal. I have proposed to this person that, dear sir, this particular model, like say a random forest regressor, is performing really well for this task of yours, this prediction task of yours, and I'm sure it's going to do wonders for your company. Just check it out. He's going to just observe. There are going to be different audits which are done on this model. He's going to refer to this profiling stage, wherein he observes like all the requirements, and if he sees that okay, all this is satisfied, then there will be a governance. He will be either approving it or disapproving it. Let's be positive and think that he's approved the model. The model has been approved. It can now go for the deployment part. Okay, this model can be pushed to deployment. Okay, it can be a real world entity, but I have to ensure that it is performing well with the real world data as well. Okay, the endpoint which is created here, that endpoint has to perform well. Now the model was it's not just from sklearn import random forest regressor. That's not all that we have. We have this model in the form of an endpoint now. That needs to be tested, and for that we have a smoke test. Okay, the smoke test can be conducted with just a couple of inputs. We just have to see with the behavior of the model. Okay, whether it's performing nicely or not. Okay, the smoke tests are basically scripts which are written, which enable you to test the performance of the model which is there in production. Okay, now till here everything is fine. What comes next is, like I said, the data is continuously changing. Now the data capture and data monitoring. Why do I need to capture and monitor the data? Again, I've given this example in the previous slide. I'll again walk you through it. Tesla has come up with its new technology. There are different companies which are coming up with new technology. We have electric vehicles, we have electric hybrid vehicles, we have different types of vehicles. Even before electric vehicles existed, we had diesel, we had petrol, we had so many different types of vehicles. A CNG. So what is the requirement? So different these different sources of fuel are going to have a different requirement. Okay, the degree of corrosion of the pipe is going to be a massive factor. Okay, the degree of corrosion, or maybe till what limit I can let my pipe to get corroded, because a car, you generally don't see them changing the pipes over and over again. So there has to be like immense power or ability of this particular mixture that I use to build the pipe. So there are so many different factors, and suddenly one fine day there's news on the newspaper that okay, blah 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 have come up with an electric vehicle. We don't have gases involved at all. Then the entire structure changes. Now what will happen to this business who exclusively make pipes? They can't just sit back. They'll have to change something or the other, because obviously there are going to be vehicles which still work on fuel, other forms of fuel. So then they have to target those companies. Okay, that their existing clients have probably turned their back on them. Then they have to go for other companies. Then they'll have to see how can they come up with a new model which satisfies the need of an electric hybrid vehicle. This is how the data is changing, and therefore the model is changing. Like, think of it like this: like the difference in the approach of the project will change altogether. Where we had petrol and diesel and CNG, and now we have electric hybrid vehicles, and then we are in the future looking forward to automobiles running on aluminium and water. So the change is quite rapid, and therefore to manage that change, you need to have a very efficient methodology, and that is what MLOps offers. Okay. The benefits will be, they're like mentioned already. The pipeline is going to be automated. Everything is like, it's kind of redundant. This is a recap slide. You could say that the benefits that you get from this is that everything is right there in front of you. The metrics, the different artifacts of production, and everything is right there in front of you for you to see. And then the execution is happening continuously in an automated way. Okay. So I think in